The next speaker is Ms. Chihiro Nakamura from the Faculty of Science. The title is Mismatch Repair Protects Against Gamma Rays in C. elegans. Please start your presentation.
Mr. Chairperson, thank you for your introduction. Hello everyone, my name is Chihiro Nakamura. My topic is Mismatch Repair Protects Against Gamma Rays in C. elegans. In short, I examined the gamma rays effect on lifespan of C. elegans, which had a knockdown factor. And gamma ray is a kind of radiation. So today's hero is C. elegans, and this picture is the first C. elegans. C. elegans is like about 1 millimeter world. Because of his ridiculous look, many people don't like him, but I become more attached to him day by day because I see him every day. So you will say, oh, it's cute. Anyway, now let's move on to the subject. Today's content are like this. Introduction about mismatch repair and this experiment. Material and method. Result. And conclusion. Well, what is mismatch repair? Usually, DNA is damaged, such as by gamma rays, UV, and so on. And damaged DNA is repaired like this. This mechanism is called mismatch repair. In mismatch repair, there are factors such as MLH1, MSH2, or AX1. In this experiment, each of these factors was knocked down, and the C. elegans was radiated with gamma rays so that DNA was broken. And knockdown means suppressing function. Under this function, I guess, broken DNA would not be repaired normally, and this would affect lifespan. That is, lifespan would be shortened. C. elegans was cultured in a plate, and it ate E. coli as feed. First, a mismatch repair-related factor in C. elegans was knocked down by transformed E. coli. And transforming means changing character to be fit for your purpose. And especially in this case, changing character of E. coli to knock down a purpose factor in C. elegans. Next, the C. elegans was radiated with gamma rays so that DNA was broken. And finally, to measure the lifespan, the number of dead C. elegans was counted by looking at the plate and checking through a microscope whether a C. elegans moved or not. And I did this check every day many times for all 8 C. elegans, because in total, 240 individuals were used in this experiment. So C. elegans appeared in my dream, and we went to a movie. Let's see the result. Result 1. In this case, MLH1 was knocked down, and the pink line means non-radiated C. elegans whose MLH1 was knocked down, and the red line means radiated C. elegans whose MLH1 was knocked down. And we can consider these two lines as similar because the p-value is more than 0.05, and p-value is a statistical indicator. If it's less than 0.05, we can judge that these two lines are different from each other. But if it's more than 0.05, we can consider these two lines are similar ones. So anyway, this means even if MLH1 was knocked down and DNA was broken by gamma rays, mismatch repair worked correctly and lifespan was not be shortened. Well, next, result 2. In this case, MSH2 was knocked down. Similarly, we can judge that these two lines are similar because the p-value is more than 0.05. That is, lifespan was not be shortened. Well, let's see the last result. Result 3. In this case, EXO1 was knocked down, and the p-value is less than 0.05. So we can consider these two lines as different from each other. However, the radiated C. elegans whose EXO1 was knocked down at a longer lifespan than non-radiated one. That is, even if EXO1 was knocked down and DNA was broken by gamma rays, lifespan was not be shortened. Well, conclusion. Even if a mismatch repair-related factor in C. elegans, MLH1, MSH2, or AX1 was knocked down and DNA was broken by gamma rays, lifespan was not be shortened. C. elegans might acquire resistance to gamma rays or something like that, or there might be another mechanism or backup system instead of mismatch repair. If mismatch repair mechanism becomes clear, it will help us for your attention.
Thank you for your presentation. Is there any question or comment? Please.
Thank you very much for your presentation. It's very interesting. I'm especially interested, obviously in Japan, radiation is a very hot topic, to get the pun, but how much do you think your research can be applied to more complex organisms, for example humans or other animals?
I won't explain to you in detail, but I don't have enough time now. So if you really want to know it, please ask me after this presentation.
Thank you. Do you have any other question or comment? Okay.
Thank you for your presentation. I have one question. How about the double knockdown? Double knockdown of MLH1 and MLH2?
Thank you for your question, and please repeat it slowly and loudly. Would you repeat your question slowly?
Double knockdown. Double knockdown. Not only one gene,
Yeah.
but also two genes. Maybe these two genes have complementary functions. How about double knockdown?
That's a very interesting idea, and now I don't have idea about it, so I want to try it in the future. So thank you for your suggestion.
Thank you.
Thank you. So please.
Thank you for your interesting talk. And you use the gamma ray as a two-dimensional source. Instead of gamma ray, for example, UV or the active oxygen, can you get a different result? My question is it dependent? Is it depend to the domain source instead of gamma ray?
Thank you for introduction. Yes, I think so, but I want to try it in the future.
Okay, thank you.
Next, please.
I think that the survival of life depends not only on the repair effect, but also for example, apoptosis or something like that. And your result is some summary of all the effects. Is it correct?
Thank you for your question. Of course, I think there are the DNA was not only damaged by gamma ray and also something like that. But in this experiment, in this case, the difference between the pink line and the red line is only depends on gamma ray effect. Of course, other factors, of course, here are not damaged by other factors, but the difference between these two lines only gamma ray. So we can consider the difference if its difference depends on gamma ray. Did you get your answer?
Yeah, but so there is a lot of effect.
Yeah.
Repair effect, apoptosis, or something, this sort of broken abnormal cells, or something like that. And so only you measured the summarized effect right? That's my question. Are there any other effects or not?
Thank you for your question. Now I don't have enough idea. So please give me a time. You give me some time and please talk it later.
Thank you. Sorry to keep you waiting, but well, the time is up. So could you please talk about your topic after the session? Okay. Thank you for your presentation.